Welcome to ACE Networks Tutorials. Today's topic is Internet Work Fundamentals. This is the part B of a Day 1 video. In my previous video, we had discussed what exactly a computer network is, what all devices are used in a network and their function. In this video, we will study different types of the network cables used in a network. And at the end, there would be a quiz, wherein I will put one scenario in front of you, and rest is the homework. Moving further. This is the topology or a network diagram that we discuss in our last video. So far, we already know the functions of all the devices used in it. By the end of this video, you would be able to tell the type of cable used between each device. Moving further. Network cables. Cable is used as a medium through which information usually moves from one device to other. Most of the networking devices use unshielded twisted pair cable, which is also called as UTP cable. Before we go further with the types of cables, let us first study what is STP cable and what is UTP cable. Moving further. Shielded twisted pair cable. On the left side, the figure shown is of a STP cable. The conductors are coated with colorful insulation, which is again protected by a copper shield. This copper shield is again protected by a plastic jacket. The entire thing forms our cable. It is never seen installed anywhere these days, or used anywhere in a computer networking. The reason is simple: the shield used makes it heavier, thicker, and difficult to install. It also requires good grounding and earthing practices. Shielding installations should be done precisely, otherwise, it will degrade the overall signal quality. It can also lead to electromagnetic interference. Moving further. Unshielded twisted pair cable. In this cable, conductors and insulators are part of the wire. As you can see, there are 4 pairs of wires. The twisted cable pairs reduce the electromagnetic interference in the cable. The more the twists, the better is the signal quality. It eliminates crosstalk as well. It is very less expensive. Due to all these reasons, the UTP cable is most commonly installed in computer networking and modem Ethernet solutions. The UTP cable shown on left, we can see, the color-coded plastic insulation electrically isolates wires from each other and identifies each pair. The twisted pair protects the signal from electromagnetic interference. Outer plastic jacket protects the copper cable. The main difference between STP and UTP cables is that STP cable got a copper shield layer which is not present in UTP cable. Copper shield makes the cable heavier. That is why mostly we use UTP cables in computer network. Now, how does a UTP eliminates ME? In UTP, pairs of cables are twisted together. The 2 wires in the pair represent the positive and negative wires of a complete circuit. When a current travels along a wire, it creates magnetic field around that wire. Environmental magnetic interference merges with that magnetic field. When the positive and negative wires are twisted around each other, their magnetic fields cancel each other out, taking the environmental magnetic interference with them. Moving further. Categories of UTP. As shown in the chart, there are categories from Cat 1 to Cat 6. The Cat 1 to Cat 4 cables were used long back, when speed was not the concern. They were used in old telephone line, token rings, and up to the speed of 16 megabits per second. With the Cat5 cables, it started using fast Ethernet, and these days, we even use gigabit Ethernet, and with the speed of 10 gigabits per second and more. In the right, you can see Cat5 and Cat6 cables. The Cat6 got more twists in the cable. The more twists, the better is the signal quality. Moving further, what is an Ethernet? We already discussed, Ethernet is a protocol. It is used for communication and connecting several computer systems to local area network, with protocols to control the passing of information, and to avoid simultaneous transmission of two or more systems. UTP cables are closely identified with Ethernet standards, that is often referred to as Ethernet cables. Ethernet can run over coaxial cables, optical fiber, or shielded cables as well. However, computer stores never label these cable types as Ethernet cable, only the UTP. Moving further, with the types of Ethernet cables. Before we go ahead with the types of Ethernet cables, we will first have a look at cable connectors. Depending upon the application, there are three types of connectors. RJ45 connector, DB9 or DB25 DCE connector, DB9 or DB25 DTE connector. DTE is a data terminal equipment, is used for devices that are initiating or controlling the serial connection, usually your personal computers. DCE is a data communication equipment, describes the device connected to the DTE, usually the modems and the printers. In the figure shown, on the right side of a screen, you can see how the connectors look like. The RJ45 connector, it got 8 pins, the DB25 connector got 25 pins, whereas DB9 got 9 pins. This is DB25 connector. Depending upon the DCE and DTE, there is DB25 DCE connector, and DB25 DTE connector. There is a slight difference between them, depending upon the application, whether it's used for console port or auxiliary cable. Moving further, RJ45. UTP cables are often installed using RJ45 connector. Here, RJ stands for registered jack. It is an 8-wire connector, usually used to connect computers onto a local area network, especially Ethernet. On the left, you can see the RJ45 connector with cable installed. You guys might have come across RJ45 connectors quite often. Moving further, DB9 and DB25 connectors. DB here stands for D-sub miniature or D-sub, is a common type of electrical connector, named because of D-shaped metal shield. It is followed by a number of pins. These connectors are designed for serial communications, that's why DB9 and DB25 connectors are used to connect your PC with a router or a switch. On the left, you can see 9 pins connector and 25 pins connector. Moving further, types of Ethernet cables. Straight-through cable, crossover cable, rollover cable. We will also discuss RJ45 to DB9 connector. Straight-through cable. It is an 8-wire cable, each colorfully coded, though the colors are not standard. In straight-through, 2 connectors are connected in a very simple way. That is, Pin 1 is connected to another end of pin 1, pin 2 is connected to pin 2 of other connector, and so on. In straight through, pins 1 and 2 are used for transmission, and pins 3 and 6 are used for receiving the data. The pins are like 1 to 1, 2 to 2, and so on up to pin 8. Moving further. Crossover cable. The crossover cables are like straight through, except the transmitting and receiving cable wiring is in crisscrossed fashion. Please note, the pins of RJ45 connector are still the same. 1 and 2 are used for transmission, while 3 and 6 are used for reception. It's just that the transmission and receiving wires are now crisscrossed. Cross 1 to 3 and 2 to 6, but you would add 4 to 7 and 5 to 8 pretty straightforward. When two hub/switches are connected to each other, or two end stations are connected to each other, a crossover cable is used to make sure that the correct pairs are connected. Now, let us study one of the most core concepts of network cables. Media Dependent Interface, MDI, and Media Dependent Interface Crossover, MDIX. MDI or MDIX is a type of Ethernet port connection, using twisted pair cabling. The MDI, for Medium Dependent Interface, is the component of the media attachment unit, that is, it provides the physical and electrical connection to the cabling medium. An MDIX, for MDI crossover, is a version of MDI that enables connection between like devices. MDI ports connect to MDIX ports via straight-through twisted pair cabling. Like devices means, MDI port connects to MDI port, and MDIX port connects to MDIX port. These both connections support crossover cable. Hubs and switches are deliberately wired opposite the way end stations are wired, so that when a hub or switch is connected to an end station, a straight-through Ethernet cable can be used, and the pairs will match up properly. The standard wiring for end stations is known as MDI, Media Dependent Interface, and the standard wiring for hubs and switches is known as MDIX, Media Dependent Interface with Crossover. We know, switches and hubs support MDIX. Rest all devices support MDI. These days, there is an auto MDIX feature in the routers along with the MDI, but the previous series of routers don't support MDIX. So, it is safe to assume, router supports MDI. Computers, laptops, tablets, and smartphones, servers, support MDI. To summarize it, two different devices, that is, one supporting MDI and another supporting MDIX, will always have a straight-through cable connected between them. Whereas, two similar or like devices, that is MDI and MDI, or MDIX and MDIX, will have a crossover cable connected between them. Moving further, straight-through cable connects MDI and MDIX. PC to switch to PC. Switches are designed to be in between two PCs communicating. Therefore, switches are created with an innate crossing of the wires. This is accomplished by switches, using the MDIX standard, which is the opposite of the MDI standard. Notice, we don't need the cable to cross the wires for us. What the PC sends on its transmitting wire, is received by the switch on its receiving wire, when the switch transmits on its transmitting wire, and it is then received by the other receiving RX wire. Therefore, when a switch is connected to a PC, it can simply use a straight-through cable. Similarly, router to switch, hub to server, PC to hub, switch to server. Moving further, both MDI to MDI and MDIX to MDIX connections use crossover twisted pair cabling. Switch to switch. What then happens if we have two switches connected? They each cross the wire once, therefore two PCs connected through to switches would have the switches crossing effect negated. Unless, of course, we introduce another pair crossing in between the switches, which is nothing but a crossover cable. PC to PC. If we have two computers connected directly to each other, and they both try to transmit on wire pair 1, their signals will collide. Moreover, nothing will be sent on wire pair 3, and therefore, neither computer will be able to receive anything. So, the cables in the wires are crossed so that on one PC, the signal sent on pair 1 from the first PC arrives on the second PC on pair 3. Both PCs are still using the MDI NIC, which means they are both sending on what they believe, but the individual wires are crossed. Similarly, hub to switch, hub to hub, and router to host. What is auto MDI or auto MDIX? I think you might notice there is auto MDI and auto MDIX feature support on network devices, like router, switch, network card, etc., before, but do you know what does it mean? It means you don't have to worry about whether to use straight-through or crossover cable. When connecting the network cable to the network device ports, any of these two cable types will work. The auto MDI or MDIX feature will auto-detect what type of cable's connected, and make it works. Moving further, rollover wired cable. Rollover cables, like other cabling types, got their name from how they are wired. Rollover cables essentially have one end of the cable wired exactly opposite from the other. This essentially rolls over the wires. But why would we need to do such a thing? Usually, connects a device to a router or switch's console port. This allows a programmer to make a connection to the router or switch, and program it as needed. You can identify a rollover cable by comparing the two modular ends of the cable. In rollover cables, the order of the pins is reversed. Pin 1 on the right-hand connector would be linked to pin 8 on the left-hand connector, as shown in the figure. Moving further, rollover cable connects computer or host, serial port, to the console or auxiliary ports of a router or a switch. Always remember, it is usually used for serial communications. Moving further, RJ45 to DB9 connector. Now, when you connect a computer to the console port of a router or a switch, you may need this kind of connector. DB9 connector is required for your CPU, whereas RJ45 connector is used for the console port of a network device. In the given case, RJ45 to DB9 connector requires rollover cable. And this is how the cable looks like. This is your female DB9 connector, this is male DB9 connector, or a serial COM port on the motherboard. These days, you got an USB, instead of these connectors, which is again nothing but a serial bus. Moving further, connecting a modem to the router. When you connect modem to a router, you always need to connect it on the auxiliary port of a router. RJ45 connector is required on the router side, whereas DB25 connector is required for the modem. As we just discussed, RJ45 to DB9 connector. Similarly, you can have RJ45 to DB25 connector and connect both the devices using that connector. Second case is, if you don't have RJ45 to DB25 connector, you can still connect it with RJ45 to DB9 connector, but now you will need one more connector, that DB9 to DB25 connector. And you are good to go. Note that rollover cable is used in this type of situation. This is what you can see in the figure shown. Moving further, connecting router to an Ethernet switch. MDI and MDIX connection. Here, you just need a straight-through cable with RJ45 connector, and you are done. Just connect one end of the wire on a LAN port of a router and another end of the cable on the LAN port of the switch. Moving further, connecting a PC, or a workstation, or a server, to a router. In PCs, you will find a network interface card or NIC card on the back of your CPU. It is installed on the motherboard. NIC card, a hardware component, is used to connect a computer to a computer network. NIC is also called as LAN adapter, network adapter, or physical network interface. NIC allows communication among computers on the same LAN, either by using cables or wirelessly. This picture shown is the wired NIC installed on the motherboard. Wireless NIC usually got an antenna connected on it. You can see behind the CPU of your machine. Wireless NIC is also present on your laptop, the antenna of which is behind the screen of your laptop. Now, coming to the topic. If you connect PC to a router, you need a crossover cable with RJ45 connector. Simply connect both the devices, as shown in the figure. Moving further, connecting an IP phone. For connecting IP phones on their auxiliary port, you need a RJ11 connector. RJ11 connector is a 6-pin connector, usually used for telephones. We need a straight-through cable for this connection. One end of the cable got a RJ45 connector, which connects an Ethernet port of a router. Another end of the cable got RJ11 connector, connects auxiliary port of Cisco IP phone. Moving further, connecting router to a router. That is MDI to MDI connection. You just simply need a crossover cable, with RJ45 connectors on both the ends of the cable. Simply connect the Ethernet ports of both the routers using that cable. Moving further, connecting a switch with a switch. MDIX and MDIX connection. You again need a crossover cable, and connect as I explained earlier. Moving further, what is a console port, and in what cases we need to connect to the console port? The console port is a management port used by the administrations to log into a router, directly without using a network connection. It is usually used when there is no display device for a router or a switch. You require terminal emulator applications like HyperTerminal or PuTTY on your PC, to modify the router or switch configuration. Normally, the console port on routers and switches is a RJ45 port. Moving further, what is an auxiliary port, and in what cases we need to connect to this port? Auxiliary port allows a direct, non-network connection to the router, from a remote location. The auxiliary port uses a connector type to which modems can plug into, which allows an administrator from a remote location to access the router like a console port. Moving further. Coaxial cable. It is used as a transmission line for radio frequency signals. Coaxial cable conducts electrical signal using an inner conductor, surrounded by an insulating layer, which is again enclosed by a shield. The cable is protected by an outer insulating jacket. This is a physical layout of the cable. The few applications of coaxial cable are RF and microwave transmission, distributing cable television signals, and computer network, internet, connections. The pictures are shown on the left. The upper one is the physical layout of the cable, which I just described. The below one is how the actual cable look like. Moving further. Optical fiber cable. An optical fiber is a thin fiber of glass or plastic that can carry light from one end to the other. Optical fibers are mainly used in telecommunications, but they are also used for lighting, sensors, toys. An optical fiber is a long, thin strand of clear material. Its shape is usually similar to a cylinder. In the center, it has a core. Around the core is a layer called the cladding. The core and cladding are made of different kinds of glass or plastic, so that light travels slower in the core than it does in the cladding. Fiber optic communication is a method of transmitting information from one place to another by sending pulses of light through an optical fiber. It is immune to electromagnetic interference. The two primary types of fiber cables are called single-mode and multi-mode fiber. Multi-mode fiber are fibers that support many propagation paths, or transverse modes are called multi-mode fibers. Multi-mode fibers generally have a wider core diameter. They are used for short-distance communication links. Single-mode fiber are fibers that support a single mode are called single-mode fibers. Single-mode fibers are used for most communication links longer than 1,000 meters. With this, we have covered almost all the types of network cables. Moving further, with the summary of all the topics we covered so far. We studied three main types of Ethernet or UTP cables: straight-through cable, crossover cable, and rollover cable. If you remember two main concepts, Media Dependent Interface, MDI, and Media Independent Interface, MDIX, you are good to go. Switches and hubs support MDIX. Rest all devices support MDI. When you connect two like devices, that is, MDI and MDI, or MDIX and MDIX, you will need a crossover cable. Examples are switch to hub, switch to switch, router to router, router to PC or server, PC to PC. Whereas, when you connect two different devices, that is, MDI and MDIX, you need a straight-through cable. Examples are router to phone, router to switch, router to hub, and if you connect PC to the console and auxiliary ports of the router, or a switch, you will have to use a rollover cable. I hope it makes sense to you. Moving further. This was the topology that we had seen in the beginning of this video. You can see the connection between like devices, router to router, or switch to switch, or PC to PC, is crossover cable. The CO over here stands for crossover. Rest all the connections are straight through cable. ST used over here stands for straight through cable. Moving further, it's a quiz time. The topology shown in the figure is what you need to look at, and the task is: name the cable used between each connection. Let me know in the comments section below. Thank you for watching this video. I will be glad if I had helped you in some way. Please don't forget to like it, share it, and subscribe my channel for more computer networking videos. See ya in my next video only on Ace Networks tutorials.